Hi folks, this is Steve with Disruptive Software. In Chapter 5 of the iCanScript Space Shooter tutorial series, we're going to learn how to count points, display score, handle game over, and restart the game. We'll also show you some more features of iCanScript. Our player can now move around the game area, and there are waves of falling asteroids to dodge or shoot at. Let's go ahead and put on the finishing touches. We will start with counting and displaying score. We will add 10 points every time an asteroid is shot down, and keep track of and display score from the game controller. The knowledge of an asteroid being shot down will be in the asteroid object, specifically in the bolt collision package. So how can the asteroid communicate with the game controller? We can use the iCanScript remote call library. Implementing remote calls consists of two steps. 1. Create a special message handler called a user function in the receiver object that will be invoked by the message. 2. Invoke this user function from the message sender using the send message function. Let's implement these steps between asteroid and game controller. For the first step, select the game controller object and right-click on the blue area. Add a user function and name it Add Score. We will create the script to add and display the score here in just a bit. The second step is to send the message. Select the asteroid object from the prefab folder. The bolt collision package will be invoked when the collider detects our shot hitting the asteroid, and just before the asteroid object is destroyed. So we will send the message to increment the score from here. Using the Library tab, look inside the iCanScript library called Communications. There are several send message functions here. We will use send message using tag, which finds the user function we wish to send the message to using the Destination Object tab and the user function name as parameters. Drag the function into the package. Set the tag port to game controller and set the message name port to add score. Make sure you type them exactly as they appear in the game controller, otherwise they will not be found. That's all we need here. Now let's create the add score script. Let's do this in a focused view by setting the add score user function as the display root. We will need an int to hold the score. Find this in the iCanScript variable library. Drag in the builder to instantiate the int and initialize it to 0. Then drag in the value equals value plus b function and connect the instance port to the builder. Set b to 10, which is what we will increment the score by for each asteroid shot. To create the score string, we will use the string concat function. Just search for concat in the library and choose one with 2 strings. Enter score, for str0, and drag the score value into str1. Notice how it automatically casts the int to a string for you. To display the score, we will use the GUI text class. Find it in the library search and look for the text input port under it and drag it in. By dragging the port directly, we avoid the additional step of dragging in the class and then using the instance wizard to add the text port. Drag the score text GUI text object into the instance port. Note that we did not use the GUI text builder. In this case, we don't want to create a GUI text object, but to use one that has already been created in the scene hierarchy. Now, connect our string, and that's all we need here. Let's see how this works. We now have scoring, and you have just completed your first inter-object message. Let's do another one. When the asteroid collides with the player, it's game over. Let's send a message from the player collision package to a game over user function that we will add to the game controller. Let's just copy and modify our first message node using Shift drag. And change message name to game over. That looks good. Now let's go to the game controller and add the game over user function. So what do we do for game over? Before we just jump in and add stuff, let's take a moment to better understand the desired behavior. When we first start, we should clear that game over and restart text that is always on our play screen. And then we want to wait a second to give the player a chance to get ready. Once a second has passed, we want to transition to playing and spawn waves of hazards to throw at the player to shoot and dodge. And once a player gets killed, we want to transition to game over, where we put up game over and restart text and wait for the player to press a key to restart. These look like states. Let's create a state machine where we can copy in the logic we have already created and add the rest. To add a state machine, right-click on the update node and add state chart. Here it is with an initial entry state. Let's rename it start wait. And let's rename our state chart game state. Let's add two other states, playing and game over. Simply right-click and add state. Then rename them. The orange state is the initial state, and the blue ones will need to be transitioned to. Let's add the transition lines by clicking on a state and dragging the arrow to the next state. Start wait will transition to playing, and playing will transition to game over. We now have a depiction of the control flow. Let's start by moving what we already have. Playing should obviously spawn the waves. So let's detach spawn waves from the timer and just set active to true. Put a package around it and spawn hazard. Now we can't just drag in the playing states like this. The reason is that each state has three packages: on entry, on update, and on exit. We can add these packages by right-clicking on the state. On enter is run once when the state is entered. On update is run continuously for every frame that the state is active. And on exit is run once when the state is deactivated. So for the case of the hazard spawning logic, we want this to be evaluated every frame. So create an onUpdate package inside the playing state like this. Then we can control drag our hazard spawning logic inside. We can now get rid of that package we added around the two hazard spawning nodes. To do so, just right-click inside the extra package and select Unwrap Package. Now let's bring in the timer. The timer should start only once as soon as we enter start wait. So let's add an onEntry package. Just right-click in the start wait state and select onEntry. Now use Ctrl Drag to drag in the start timer node. Since the start message handler is now empty and we no longer need it, feel free to delete it. So where should we check for is time elapsed to trigger a state transition to the playing state? In the transition package, which is used to contain the logic that causes a transition to occur. Just double click on it to uniconize it and unfold it. Now drag in the isTimeElapsed function. Rename the transition isStartWaitingElapsed and connect isElapsed port to the transition package trigger port. Let's iconize it again. Now let's create the transition logic from playing to game over. Again, uniconize it and unfold it. Name it isGameOver. We will create a boolean here that will track if our GameOver user function is invoked. Drag a bool builder into the transition and leave it initialized to false. We will set it to true by dragging a bool input port into the user function, setting it to true. and connecting the instance ports. Now drag a bool output port to the transition package, connect the instance ports, and connect it to the trigger. Collapse and fold the trigger. Now let's take care of our game over and restart text. We can clear the text as soon as we start in start wait, so we can do it on the onEntry package where we already have the timer. Find the GUI text class in the library. Now drag the text input port into the start wait onEntry. Drag the game over text object into the instance port and set the text to blank. Just click on the string to add the double quotes. Let's clear the restart text as well. Just copy the GUI text node by using shift drag and change the instance of the copy to restart text. We will want to display game over and press R to restart strings when we enter the game over state. So right click inside the game over state and add onEntry. Copy both GUI text nodes by selecting them and shift dragging them over. Set the instance by dragging the GUI text objects from the scene hierarchy. And add the text as follows: game over, and press R to restart. That should do it for the on-screen text. All that is left now is to handle the restart. We will check for the R key being pressed every frame during game over, so add the onUpdate package to the game over state by right-clicking and selecting it. To check for the key press, use the get key down function. Just search for it in the library and drag the one with the key code input. Set the key to R. To restart, we can do a load level. This will destroy all objects. Find it in the library and drop the one with an index in. Add an enable port and connect it to the output of key down. What level shall we load? We can just load the current one by dragging in loaded level and connecting the nodes. So there is our completed state machine. Now, let's see if all this works. Hit run. So far so good. The game over and restart text is gone. Scoring works. And when I get killed, I see the game over and restart text, and the asteroids stop falling. Now, when I press R, the messages go away, the score is reset to 0, and I'm alive again with asteroids falling. Fantastic! Our game is complete. All the basic functionality per the Unity tutorial is done, without a single line of code. Let's do some final cleanup. Now that we are done, we can remove unneeded ports from our message handlers to declutter things. Just right-click on them and select Remove Unused Port. If you ever need to add new functionality that requires the ports you have removed, you can just right-click and select Update Message Ports to get them back. Thank you for watching the iCanScript Space Shooter tutorial series. If you have any feedback or issues with the series or iCanScript, we would love to hear from you. To do so, just go to Help and Support on the iCanScript website or email us at support@icanscript.com. And please remember to subscribe to our YouTube channel and like us if you find these videos useful.